Good morning, sir. I am John Fos Elicy Amakna from BSET 1C, and this is my recitation video. Number 1. What is a rectifier circuit? It is defined rectification is the conversion of alternating current or AC to direct current or DC. This involves a device that only allows one-way flow of electric charge. As we have seen, this is exactly what a semiconductor diode does. The simplest kind of rectifier circuit is the half-wave rectifier. Rectifiers are essential circuits for power supplies that convert an AC input voltage into a DC voltage supply that can be used to power electronic circuits. In electronics, rectifier circuits is the most used circuits because almost every electronic appliances operates on DC or direct current. But the availability of DC sources are limited, such as electrical outlets in our homes provide AC or alternating current. There are two types of controlled rectifiers, and they are half-wave controlled rectifier and full-wave controlled rectifier. Half-wave controlled rectifier has the same design as the half-wave uncontrolled rectifier, except we replace the diode with an SCR. Related links: full-wave rectifier or half-wave rectifier. Using a rectifier in power supply helps in converting AC to DC power supply. Bridge rectifiers are widely used for large appliances where they are capable of converting high AC voltage to low DC voltage. A junction diode offers to allow resistance to current in one direction when forward base and high resistance in the other direction when reverse base. Number 2. How filter circuits for AC to DC power supply works. The inductor opposes the AC component and passes only DC towards the load resistor so that the voltage across the load is DC voltage. The working of this filter depends upon the current through it. For higher current, the reactance of the AC component is more and hence in filtering action is better. A filter circuit comprises of generally inductor and capacitor. The inductor allows DC only to pass through it, and capacitor only allows AC to pass through it. Thus, a circuit formed by a combination of inductors and capacitors can effectively filter the signal according to the application. An EMI filter for a power supply typically consists of passive components containing capacitors and inductors connected to form LC circuits. The inductors allow DC or frequency currents to pass through when restraining the undesired high-frequency currents. The purpose of AC side harmonic filters is to suppress the flow of harmonic currents into the connected AC networks. The DC side harmonic filters are restricted to flow of harmonic currents in the DC pole and electrode lines, thereby avoiding the telephone interference. Thus, the output of the rectifier has to be past the filter circuit to filter the AC components. The filter is a device that allows passing the DC components. The load of blocks the AC component of the rectifier output. Thus, the output of the filter circuit will be steady DC voltage. The purpose of power supply filters is to smooth out the ripple contained in the pulses of DC obtained from the rectifier circuit while increasing the average output voltage or current. Filter circuits used in power supplies are two general types, or what we call capacitor input and choke input. A good power supply filter can be built from a single inductor and damped capacitor. This is called an LC filter. Other designs are possible with more or fewer components. A line filter is a device that meant to reduce the EMI, allowing other devices in circuit to function properly. Though most electronic appliances come equipped with their own noise filters, There are cases in which an external filter has to introduce, for example, in unconventional means. The four primary types of filters include the low-pass filter, the high-pass filter, the band-pass filter, and the notch filter, or the band reject or band stop filter.
Voltage multiplier. The voltage multiplier is a type... Ay, wala day ko. Number 3. What is a voltage multiplier? Voltage multiplier is a type of diode rectifier circuit which can produce an output voltage many times greater than of the applied input voltage. We saw that the DC output voltage being controlled by the rectifier is a value that of the mains input voltage. The voltage multiplier, however, is a special type of diode rectifier circuit which can be potentially produce an output voltage many times greater than of the applied input voltage. Although it is a cash usual in electronic circuits to use a voltage transformer to increase a voltage. Sometimes a suitable step-up transformer or a specially insulated transformer required for high voltage applications may not always be available. One alternative approach is to use a diode voltage multiplier circuit which increases or step up the voltage with use of a transformer. Voltage multipliers are similar in many ways to rectifiers in that they convert AC to DC voltages. For use in any electrical and electronic circuit applications such in microwave ovens, strong electric fields, coils for cathode ray tubes, or electrostatic and high voltage test equipment, where it is necessary to have a very high DC voltage generated from a relatively low AC source. Generally, the DC output voltage or VDC of a rectifier circuit is limited by the peak value of sinusoidal input voltage. But by using combinations of rectifier diodes and capacitor together, we can effectively multiply this output peak voltage to give a DC output equal to some odd or even multiple of the peak voltage value of the AC input voltage. Consider the basic voltage multiplier circuit. One of the diodes is conducting in each half cycle the same as for a full wave rectifier circuit when the sinusoidal input voltage is positive.